Step outside tonight. Find a patch of sky with no clouds, no streetlights bleeding orange into the dark. Look up, give your eyes a full minute to adjust, and then find it, that steady, yellow-white point sitting where it always sits, doing what it always does. The sun. You have looked at it your entire life. Or rather, you have not looked at it, because staring at it directly is one of the few things the universe will punish you for immediately, without warning, without a second chance. It is so bright it damages you, so close it warms your face through a window on a winter morning when the temperature outside is trying to kill you. It is the most familiar object in the history of human experience. Every culture that has ever existed on this planet has built something around it. A calendar, a god, a story. It rose this morning. It will set tonight. You have watched this happen thousands of times. You think you know this object. You do not. Here is what you actually know. A surface, a glare, a warmth. You know the sun the way you know a stranger's face through a frosted window. The general shape, the general brightness, none of the interior. What is actually happening inside that thing right now as you stand on your patch of ground and breathe your ordinary air is so extreme that no material on Earth can contain it, simulate it, or survive it. At the sun's core, the temperature is 15 million degrees Celsius. Not 15 million degrees like an oven cranked to its limit. Not 15 million degrees like an industrial furnace, like a welding torch, like anything you have a frame for. 15 million degrees is the temperature at which hydrogen nuclei stop being separate things. They collide so hard, so fast, so relentlessly that they fuse. Two hydrogen atoms pressing together until they become helium, releasing in that single instant a pulse of energy that will take 100,000 years to fight its way out through the layers of the sun before it finally escapes as the light hitting your face right now. The light on your face left the core of the sun before modern humans existed. Let that sit. Every sunrise you have ever seen is ancient. The warmth you feel is 100,000 years old by the time it reaches your skin. The sun is not just a star. It is a time machine broadcasting the past into your present, continuously, without pause, for 4.6 billion years. And it will not do this forever. And that is the thing people forget about the sun. They treat it like furniture, like it was there before you arrived and will be there long after you leave. Permanent in the way that mountains feel permanent, ancient in a way that makes change seem impossible. But the sun is not a fixture. It is a fire, and every fire, no matter how enormous, no matter how old, has a last moment. The sun is burning through its fuel right now. Every second, it converts 600 million tons of hydrogen into helium. Every second. That number is so large it has no meaning until you frame it correctly. The entire mass of Mount Everest, gone, every 2 seconds, just to keep the lights on. And the sun has been doing this for 4.6 billion years. It has been burning at this rate since before the Earth had oceans, before the first cell divided, before anything on this planet drew its first breath. And it has roughly 5 billion years of hydrogen left. That sounds like enough. That sounds like the conversation should end there. 5 billion years. Problem solved. Worry about something else. But the end of the sun's hydrogen is not the end of the sun. It is the beginning of something stranger, something slower, something the universe produces in enormous quantities and then leaves sitting in the dark for longer than anything else in existence. Something that, right now, is burning quietly in the space between stars. Something that will still be there, changed almost not at all, 1 trillion years from now, when the universe is so old that the stars we see tonight will be memories. Keep watching, because the thing the sun leaves behind is not ash. It is not debris. It is not silence. It is a kind of light the universe has almost infinite patience for. To understand what the sun becomes, you have to watch it die. Not in one moment, not in an explosion, not in a flash. The sun's death is a slow process measured in hundreds of millions of years, each phase stranger than the last. What follows is not speculation. This is what we have observed happening to other stars. This is what the physics requires. This is what is coming. In approximately 5 billion years, the hydrogen at the sun's core runs out. The fusion stops. And when fusion stops, the force that has been pushing outward against gravity, the constant explosion at the center that keeps the sun from collapsing under its own weight, weakens. Gravity wins. The core contracts, heats up, and in that heating, something new ignites. Hydrogen burning in a shell around the core rather than inside it. This changes everything about the sun's shape. The outer layers respond to the new energy source by expanding. Slowly at first, then faster. The sun grows. It becomes what astronomers call a red giant, swelling outward until its surface reaches, by current estimates, somewhere near the orbit of Earth. Some models say it stops before us. Some say it swallows us entirely. Either way, the Earth's oceans will have boiled away roughly 1 billion years before this point. The atmosphere will have been stripped. The surface will be bare rock baking at temperatures incompatible with any chemistry we associate with life. Long before the sun physically reaches us, it ends us. But the red giant phase is only the middle chapter. After the sun exhausts the hydrogen shell, it begins burning helium in its core. This is a more violent, more unstable process. The sun pulses, dims, brightens, sheds its outer layers in enormous gusts of gas called stellar winds. These expelled layers drift outward into space, expanding into a glowing cloud surrounding the remaining core. From a distance, through a telescope, this looks like a ring, like a bubble, like a flower made of ionized gas lit from within. We call this a planetary nebula. The name is wrong. It has nothing to do with planets. It is simply what the outer shell of a dying star looks like when it is drifting away. And at the center of that drifting cloud, something is left behind. The core. Compressed by gravity, but no longer able to fuse anything. No more hydrogen, no more helium. The temperatures and pressures not high enough to ignite the next fuel. What remains is a sphere of carbon and oxygen, roughly the size of Earth, but with a mass somewhere around half the sun's original mass. Compressed so tightly that a teaspoon of its material would weigh approximately 5 tons on your bathroom scale. This is a white dwarf. It is not burning in the way the sun burns. There is no fusion happening inside it. It produces no new energy of its own. It is simply hot, enormously hot from the compression and the history of everything that came before. And it radiates that heat out into the surrounding space, slowly, steadily, the way a stone pulled from a fire radiates warmth. It glows white because it is so hot. It will glow for an almost incomprehensible amount of time. Here is the gut punch, and the universe is currently 13.8 billion years old. In all of that time, not one white dwarf has had enough time to cool down completely. Not one. Every white dwarf that has ever formed, and there are estimated to be somewhere around 10 billion of them in our galaxy alone, is still radiating heat, still glowing, still warm. The cooling process takes longer than the current age of the universe, which means we have never seen what comes next. We know it theoretically, we can calculate it, but no human eye, no telescope, no instrument has ever observed a white dwarf that has finished cooling. What lies at the end of that process, a completely cold, completely dark, crystallized remnant, is called a black dwarf. And black dwarfs, as far as we know, do not yet exist anywhere in the universe. We are too early. The universe is not old enough to have made one yet. The white dwarf that the sun becomes will sit in the dark, cooling, for trillions of years. 1 trillion years. 10 trillion. The number stops meaning anything after a certain point. But try. 10 trillion years from now, the Milky Way as we know it will no longer exist. The stars currently forming in nebulae across our galaxy will have lived their entire lives and died. The stellar nurseries will have emptied. The sky, as seen from wherever Earth's remains orbit, will be darker, quieter. Most of the stars will be gone, and the white dwarf will still be there, still warm, still glowing faintly, a dim ember sitting in a dark that has grown so complete that the faint light it puts out has almost nothing left to illuminate. This is the object that replaces our sun. Not a black hole, not a neutron star. Those are for more massive stars, stars heavier and more violent than ours. Our sun produces something quieter, something that persists longer than almost anything else the universe makes, something that outlives nearly every other structure in existence. But here is what you need to sit with before we go further. That white dwarf, that quiet, compressed, slowly cooling remnant, will contain, locked inside its crystallized carbon core, the atoms that once burned in the heart of our sun, the same carbon that was forged there, the same oxygen, compressed into something that physicists believe will, over trillions of years, crystallize completely. The sun will become a diamond the size of a planet, sitting alone in the dark, for longer than the current universe has existed, multiplied by 1,000. What does that mean for us? Come back down. You are standing on a rock that orbits a burning sphere of hydrogen 93 million miles away. That rock is 4.5 billion years old. The sphere it orbits is slightly older, and somewhere in the future, a future so distant that the word future barely applies, this system ends quietly, not with a bang, with a cooling. The impulse, when confronted with facts like these, is to feel small. Resist that impulse, not because it is wrong, but because it is incomplete. Here is what the scale actually reveals, if you look at it clearly. You are a temporary arrangement of atoms that has, against all odds, developed the capacity to understand the object that made it. The sun did not just provide the warmth that allowed life to emerge on Earth. The sun is, in a more literal sense, the origin of everything in your body that is not hydrogen. The carbon in your cells, the oxygen in your lungs, the iron carrying oxygen through your blood. These were forged in stellar interiors, not necessarily this sun, but stars like it, stars that lived and died before our solar system formed, scattering their material into the cloud that eventually collapsed to become everything here. You are, in the most non-metaphorical sense possible, made of dead stars, and you are standing on a planet orbiting a star that will itself one day become the kind of object that made you. There is a circularity to this that feels designed, but is not. It is simply what physics does. Given enough time and enough matter, stars form, stars burn, stars die. Stars leave behind compressed remnants that sit in the dark and cool for longer than anything else survives. And the material they scattered when they died becomes the next generation of stars, the next generation of planets, the next generation of whatever manages to arrange itself into something capable of looking up and wondering. The white dwarf is not the end of the story. It is the archive. Think about what a white dwarf actually is. It is the compressed memory of a star's entire life. Every fusion reaction that ever happened in the sun's core, every photon that fought its way outward, every solar flare, every pulse, all of that history collapses down into something roughly the size of Earth, crystallized, preserved, radiating it slowly outward into a universe that, by the time the white dwarf finally goes cold, it will have changed beyond anything we can currently describe. There is something almost unbearably quiet about that image. 1 trillion years from now, give or take the kind of timescale that makes 1 trillion years feel like a rounding error, whatever exists in what is now our solar system will orbit a dim, cooling remnant. No warmth to speak of, no light worth calling light, the kind of darkness that makes our current night sky look like noon. And the white dwarf will still be there, cooling toward absolute zero, 1 degree at a time, over a time span that dwarfs the entire current history of the universe so completely that our 13.8 billion years would be, proportionally, the first breath of a being that lives for centuries. We will not be there to see it. Nothing alive today, nothing alive in the next billion years will witness the sun's transformation into its final form. The timescales involved are so far outside human experience that the word patience doesn't even apply. The universe doesn't wait. It simply continues. Stars form and die without needing anyone to watch. White dwarfs cool without needing anyone to notice. The carbon crystallizes in silence, in the dark, with a precision and a completeness that requires nothing from us. But we noticed anyway. That is the fact worth sitting with. Not the trillion-year cooling time, not the 5-ton teaspoon, not the diamond the size of a planet drifting in the dark. Though all of those are real, all of those are coming. All of those are written into the physics of what we are part of. The fact worth sitting with is that a species that has existed for roughly 300,000 years on a planet that has existed for 4.5 billion years, orbiting a star that has been burning for 4.6 billion years. That species looked up and measured and calculated and found the ending, found it before it happened. We will never see a black dwarf. The universe hasn't made one yet, but we know they are coming. We know what the sun will become. We know the sequence, the timeline, the physics of the last light. There is something in that knowledge that does not make us smaller. It makes us strange. Strange in the best possible way. The only species we know of, in the only universe we know of, capable of holding 1 trillion years inside a 3-pound brain and feeling the weight of it. Tonight, when you step outside and find that familiar point of light sitting where it always sits, remember that it is dying at the rate of 600 million tons per second. Remember that the light reaching your eyes is older than your species. Remember that in 5 billion years, something quiet and compressed and crystalline will sit in its place, cooling in the dark, patient in a way that has no word in any human language. And remember that you are the only thing in the known universe that will ever know this. The sun will burn on. For now.